How
So
many
the
more programs are there, ma'am?
see, like in CapsTurn, they are like around six, and CapsMill, they are around six. I am doing three programs on CapsTurn and three on CapsMill, and like which have different operations. So the similar one I'm just leaving in.
Yes.
Okay, so you have to see that you will complete the record at the earliest. I need to finalize everything. I have given the due dates also. And one more thing, you are requested to come down to the college from 28 for your lab sessions.
Yes, ma'am.
Yeah. What about that? We didn't get any exact information related to this from the students' end. So if that is so, 28th and 29th will be for B1 batch. Okay, so all the programs, what you have been taught virtually, so that you can practice like 2 days for each batch. At least you will get some hands on physically how to operate, so that it will be somehow useful for your external examination, which has to be taken care.
Ma'am, only on the specified date should we come, or can we come later also, ma'am? Because
No,
30th
it
we have phase one project presentation.
yeah, it is like from 28th to 2nd they are telling, and it is difficult for me to stay back after 31st. I need to complete all the things. So as B1 batch, if that is the case, if it will be really helpful if you come down on 28th and 29th.
Yes, ma'am.
Okay. So in that aspect, I just wanted to complete the virtually all the programs to be taught. So if I will take today one program on CapsTurn and two more on CapsMill. So remaining, I'm thinking to complete either on tomorrow is an holiday for you all. Saturday afternoon, yeah, Sunday afternoon, whichever is convenient. Kindly let me know. I will go through the other programs so that on 28th and 29th you can really practice with the concepts which has been explained to you, or else at that time if we start about the explaining part, so you won't be able to do it actually on system. Okay, so in that aspect you just let me know your convenient date, either on Saturday afternoon or Sunday afternoon, so we will plan accordingly. So now let me start up with the, I think the slide is visible to you all. Hello.
Yes, ma'am.
Okay, so this is the program number six, what we will be doing on our CapsTurn. So we have written the program for this program, or for this blank already, right? Manual part programming. And we have dealt related to this, the coordinate systems also, right? The same coordinates for turning, it is always very easy, as we have only two axes. One is the z axis, another one is the x axis. So if you go towards your left, it is negative. If you go towards your right, it is positive. And above this reference line, it is positive x, and below this it is negative x, so that you are aware and you know how to take the coordinates also. So here when you look in the given part, you have to see that you need to do like regular turning operation, and you have an thread cutting operation also, what we need to do. Apart from that, we have grooving, so which is of both what we say, the axial grooving as well as the radial grooving. So all these operations now has to be done in our caps turn. So for that, what is the first step? The step is as usual what we followed in the other caps turning operations. So we will be providing the coordinates only for the half part of the part which has to be developed. Right? So once the coordinate has been given, the line diagram will come for this part. So after that, what we have to do is you have to create the dimensions for the blank. So the blank dimension should be more than that of the part which has to be created. Right? So then when you go for machining, the other part which you will not show it, so that will be visible automatically. So then you need to select the tool which are needed for face turning operation, for turning operation, as well as for grooving operation. So So as per the pitch given, so I'll show you how to change the required specifications so that you get the required thread cutting and grooving operations as well. And after that, we need to generate the program for the part what we have created. So the procedure what we followed for the other programs in CapsTurn in the previous class is the same. Only thing, the operation changes here. Due to the operation changes, you need to change a different tool. And coordinates, we have discussed about that in our previous CNC turning operation, the same coordinate system. So we'll start from here, the reference point. So we won't give the overall dimension of the blank here for each block. So you'll just give half of it. Okay. So similarly, we will provide the coordinate system and complete. Uh, I'm not going to explain you again the coordinate system. You people has to tell me the coordinates when we go to the software part, right? So this is the same part what we need to create now using CapsTurn. So let us kindly take down the image, a snapshot of this diagram. It is needed for you to let me know the coordinates. So after that, I will just start up with the software part. Have you people have taken down the drawing? Yeah, at least the snapshot of it.
Yes, ma'am.
Okay. If that is so, I will just end the presentation and go for the software directly. Is my screen visible?
Yes, ma'am.
Okay, so as usual, you go for CapsTurn, do the double click, the window gets open, right? So then for the startup, it asks you to create a new part. So when you open, this is the work setup which gets. So I have explained the work setup sheet in the previous program also. You need to select the material which is free to perform the operation. So you go for the material steel, which is for cutting. Okay, so you will go with steel here, stay, which is for free cutting. So select that, right? So holding is always external. Don't make any changes. The job position you should give. So I have explained why it is 110 in the previous. So you'll be having the job. You have to see the dimension of the job. In between, at least we need to give 5 or 10 mm clearance. And the jaw, it holds, right? At least, so this is our blank. Okay, so this is the entire blank. From here till here, we have the blank. And from here till here, suppose we need to do the operation on the blank, you have to give some allowance here in between the jaw and the part where you need to do the operation. So this will be usually like 5 or 10 mm, what we give the allowance. Apart from that, you have to give the dimensions such that the jaw will hold. For the jaw to hold the blank at one end, at least 20 or 30 mm has to be given. So this entire length will holds good for 110. So if you write positive 110, it will come in the other way. So kindly type it as minus 110 so that it takes the dimension towards your left hand side. So kindly provide the jaw position accordingly. Okay, so the clearance value Z, always it is preferable to give 1 mm so that before starting, the tool will be somewhere nearer to the blank and it will not be touching. So give a positive value. It is not needed more than 1 mm. Okay, so just give the clearance value as 1 mm. Okay, so after that, you can press OK. Yeah, the clearance outer diameter, you just check the diagram and give the outer diameter. After that, you will go for drawing the line. You have to use the line command, right? So as I explained you in the problem, you will be just providing the coordinates for the upper part. So the lower part will be displayed automatically when you go for machining process, because only the coordinates for half is needed. The other half, since it is a turning operation, it will take automatically. But in case of drawing, in case of writing the part program manually, we used to give the entire diameter of the blank. But while doing the reverse, drawing the part and generating the code, you will be just giving half the coordinates. Okay, so that is the case where you will start up with the coordinate system now. So usually you start up with x0 and z0. So after that, kindly, now I don't have the image with me. I have closed my PPT. See the coordinate. Next, what you have to get after it is x0 and z0, you have to come up now. What is the coordinate? I think it is x will be 10 and z will be 0. Is it so? Kindly check the diagram of the PPT.
Yes, ma'am.
Right, so I don't have the reference. I have closed my PPT over here, so kindly cross check. So x will be 10 here and z will be 0, so the line has been come over here and then it has to move towards your left. So x remains same, z it is going in negative direction, I guess, for 40 mm, and hence now x is 10 and z is minus 40, so you have got this line over here. So then I guess you have a groove cutting at this option. So you have an axial groove cutting operation. Please look in the diagram. So for that you have to go for grooving. So if you see here the image what I'm showing, this is for grooving. So you have to click this. It asks you which is the width you need and what is the depth of grooving which has to be taken place. So it is an axial groove cutting. So you have to provide the width accordingly. So what is the width you need the groove? If you look into the sketch, I guess
10,
is
ma'am.
it 10? 10. So you will give the base width as 10 and the required depth as 3. So you can see the slot for the groove. So now where you will fit, you have to again give the coordinate here, x 10 and z minus 40. So then it will come and sit over here directly. After that, you need to proceed further. Again, you see whether you have a linear interpolation or anything related to the arc. So you have to refer for the image every time. So grooving is done. So next again you have to go for line command. So again specify the start point from which you want to do it. So it was extend z minus, it was extend and z minus 40. So now you have done the grooving for a width of 10 mm. So I don't think so why this word file. So just provide the coordinate from here till here and the linear interpolation coordinate. You have to check and let me know the coordinates, or else it will be difficult for me here. I haven't taken the image also. So after this linear interpolation, again you have one more groove. What you have to, let me take a snapshot of. Yeah, so You have two axial groove cutting operations. So one is done, the other one to be done. So I just took the image of the part which I need to do it. So as per that, after this groove, right, you have a linear interpolation for 5 mm. So the coordinate here was x10 and z minus 50. So here it was z minus 40. Now, so now it is z minus 50. So from here till here, it was a dimension of 5 mm. So x remains the same. So it is x10 and this is z. So here it was 40. So this is 50. So it is minus 55. So after this, you had an varied length for tapering. So right. So here again, now the x has been increased. Overall diameter of the blank is 35, means it is 17.5. So here x will be 17.5 and z will be 55 plus 10, so it is minus 65. So after this, you had again a linear interpolation for 5 mm. So here x will be again minus 17.5, sorry, plus 17.5, and z will be 40, 55, 65. So Z will remain 65 at this point. So after this, we have the groove cutting operation again. So we need to start with the groove cutting operation. So you have to go for groove cutting. And now again, you have to provide the width. So width is again 10 mm, right? So you will have to provide the coordinate. Again, x is equal to my 17.5 and z is minus 65. 65 plus 5, I guess. 65 plus 10. What was the coordinate? I didn't see. It's always better to write and keep the coordinate. It is minus 75. It is minus 70. Okay, I missed 5 somewhere. So after this, you have to again start the coordinate system, right? So go for line command. From here you have to give, so x is 17.5 and z is minus 80. Okay, so from there you have 10 mm. So again x will remain 17.5 and z was minus 80. You will add minus 10 again. It will be minus 90. So now we are done with half the part. So once you have created the line, always remember you have to go for draw and you have to define the contour and you have to define the part. The color gets changed. Without defining the contour and defining the part, you cannot perform any operation. So after writing the coordinates, be familiar with the coordinate system. Write down the node number 1, 2, 3, 4, 5. Okay, so this is 1, 2, this is 3, 4, 5, 6, 7, and 8. Write down the coordinates for 8 on a paper and keep it ready. So then you will start up with the CapsTurn. Start from x0, z0 and give fatafat all the coordinates. This line gets generated. So once the line is generated, then you go for draw and define the contour. So go and define the contour. You have to go for auto contour. So it asks you, do you want to save? So you will just save S. So the color got changed. But you can observe the groove what we have done is not been selected. Right? So now when you go for creating the part, it will select. But you observed it will select, but it has changed only the lines what you have created and not the grooving part. So that remains the same. And then you have to now go and save. So it is shown twice. I don't know why. So it is defining the contour again. Then again the part has been created, defined. So when the part is defined, okay, so color gets changed from red to pink. So once this is done, what is the next step I have told you? You cannot start without giving the dimensions for the billet. So in the question, you have to provide the blank size also. So usually in the question they give you the billet size. So as per that you will provide the length here. So to provide the length you have to see what is the overall length needed. So overall length needed is 90 mm, right? So apart from that you should see the 5 mm allowance, right? In between the jaw and the workpiece where you want to do the operation. So 90 plus 5 becomes 95. So after that you have to provide the dimension for the jaw to hold. So 95 plus 30 also you can keep, or 95 plus 20 also you can keep. Accordingly the length gets changed. Okay, so as per that, you will give the blank size, and then the diameter. The diameter of the billet should be slightly more than that of the required. So you can see here the overall diameter of the blank in the image which we need to do is 35, right? So if you divide 35 by 2, how much you get? 17.5, right? So roughly it is 18. So you will give 1 mm allowance more for the blank size. I guess you are understanding how to give the dimensions for the blank diameter and length. Any doubt on this? Hello? Hello? Are you people there?
Yes, ma'am.
Understanding?
Yes, ma'am. Ma'am, so in the exam directly we can start off with the software now, ma'am. There is nothing to write.
No, 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 nothing. You need to draw the part diagram. Okay. So if they ask you to explain the procedure, you can explain orally, but you won't be writing any manual programming here. Just draw the part. You will directly go for the CapsTurn. You will create and you will generate the program, and you need to take the printout of other things at the end what I'll be going to explain you. Okay.
Yes, ma'am.
So it is nothing much more to write here. So accordingly, the blank dimension what you give for that also you have to give half the diameter only, but don't give exact diameter. Exact diameter of the part what we need to do is 17.5 because the diameter of the blank required is 35 mm. But we will give 1 or 2 mm allowance extra for the blank size, and hence here the diameter we are giving as 19. And always you need to give the value of z as 1 so that the blank size will be outside the part what we need to do. If you give 1 it comes exactly on the part. Okay, so you need to give an allowance of 1 mm minimum, so we are giving z value to be as 1 mm. So once that is done you can see that half the part of the blank is being generated. So when we go for machining, so the remaining part will be visible for us. So then you go for machining. So now you can observe the minimum part of the blank is also being seen. So then you have to go for facing operation. You need to remove the facing part, and then you need to do the turning operation. For all those we need to select the tool. So we have to go and select the tool one by one. Okay, so after this you will go for plane facing operation. Select the tool for that one. You need the facing operation for rough finishing. In that only you will do facing and turning. Another one finishing tool, right? So this is for rough turning operation. The general nomenclature, let it be the same. Don't make any changes. You just press OK to it. Only thing you just check the required nose radius is available. So then you have to show from where to where you need to do the facing operation. So you have to, after clicking the facing operation, you have to use the cursor and select from where to where you need. Okay, so I'll just a second. I've made pause. So now you can select from which end to which end you need to do the facing operation. So once that is done, if you zoom out, it will show you from where to where the facing is to be done. So then it shows how the facing has been done here. If you give an overshoot value of 1, the excess material will be retained as explained in the previous sessions. So see that the overshoot value will be kept it as 0. Okay, so the depth of cut you please give as per the requirement. So that is done for facing. Okay, so the same tool you will be using for turning operation also. So one tool has been selected. So then you need one finishing also, finishing tool. So for finishing tool again you select from where to where you need to do the finishing operation, right? So again from here till here you will select. So it will help in doing the finishing operation for the face turning. So now you have two tools. One is for the rough turning, another one is for the smooth finishing. So it is shown again for your understanding the same thing. So you have the two tools here which has been listed out. It has been repeated again and again. Let me. So you can zoom in and zoom out the part exactly. Okay, so it will be able for you to understand. Another thing, you have to select the turning operation from when to when you need. So this end to this. So entire part has to be done for rough turning. So when you're doing rough turning, finishing also has to be done. So it is always better to give the required finishing allowance. Okay, no need to give a huge gap in between. Point 0.1 or zero point 0.2 mm of finishing allowance will be the enough value. Okay, so now before doing the operation you need to give the finishing allowance also. So kindly give the value for finishing allowance as 0.1 or zero point 0.2. If you give as 0.1 it will be very difficult to identify the difference between the rough turning and the finishing. So it is preferable to go with 0.2 mm. So here we are giving 0.2, and depth of cut you give how much has been needed. It is not 11.2, it is 1.2. Okay, it has been given as 1.55. Then you can calculate the total depth which has been needed. So the total depth will be like overall diameter of the blank was 35. So you do 35 divided by 2. So it is 17.5. Again 17.5 divided by 2. Right? So based on that, we will give the value nearly to it. So how much you get if you divide 17.5 divided by 2? It is roughly 8.75. So here it has been given as 8, right? So you can round out to the highest number or you can round out to the previous number also. So roughly we take the value as per the calculation, and in this aspect the overall depth of cut was taken as 8 here. Okay, so you need to calculate and give a rough value for the depth of cut. I think this is still previous. The allowance, yeah, depth of cut was given as 8, right? So after that you will press OK. So now you can notice you have two different lines. This is the pink one, the rough turning one, and this blue color one more which has been visible is the finishing. So in between you have like 0.2 mm of allowance. So the rough turning tool will do the turning operation, rough turning and rough facing. And then the finishing tool what we have selected will do the finishing operation for the turning as well as the facing operation. So we have set the two tools already, right? So now next you have to go for grooving. So since we have an radial grooving and axial grooving also, you need to select the tool. So you went for grooving operation and you have to select the tool for it. So go for radial grooving here. So select the unit as mm. So here you have to go for grooving, right? So here it is 12 into 12. So this is the holder width of 12 mm what you have, and the corner radius is of zero point 0.2, and the tip width is of 2 mm. So whether you select hand of tool either left or right, so the program automatically takes, okay, so even though we select or not, so no need of selecting either left or right oriented. Just see the required dimension and you show from where to where you need the grooving operation. You need to select from here till here, okay, so that it will do the required grooving operation. So here you need to tell whether you need an external grooving, right? So it is by default. So then you have to provide again the allowance. What is the finishing allowance you need? What is the peck depth which is being needed? So kindly give the peck depth value, okay. So it will perform the operation accordingly. Once the peck depth value is given, it will take the finishing allowance and complete the other part of the finishing aspect as well. So for that you need to select from where to where. So you have selected, the same thing is shown here again. So by varying the finishing allowance, you can see what difference you will be getting. Previously it was 0.02, now they took 0.2 and showed you the difference. So now the selection for the radial grooving is also being done. Then we need threading operation also to be done, right? As per the given diagram, you have a threading operation and external threading operation. They have given the dimensions of the pitch also. So we have to do, right? And you have an axial drilling also. For that you need an drilling tool. So we have to go for the libraries, they make the unit in mm, select the central drill and which is the diameter you need. So based on that, you need to select the drill bit. So here the operation name by automatically it comes as drill. You have to check what is the hole depth needed. So in the question it is like 10 mm. So as per that you give the value as 10 mm. So that is done. Okay, so you have set. Then you have to go for threading. You have a threading operation, external thread cutting. So kindly click external thread cutting, right? So there, if you go back, you can observe external thread cutting. It is like holder width is 16, right? Holder width will be 16 here, and maximum thread depth we can get will be 3 as per the specification. So then you have to check the dimension from where to where you need. So we need from here till here, right? So you have to zoom and be specific to click from where to where you need. Okay, so this is the line in which we need to perform the thread cutting operation, so that it performs a required external thread cutting as been shown here in the simulation. So if you specify you need an left hand thread, so it moves from left to right. So if you need from right to left, so it moves from right to left. So it depends upon the requirement. So which type of thread you need basically. So here the pitch value you need to give. So in the question you need to check what is the pitch value given. So if you go back to the sketch here, so you can see it is of 1.25 is the pitch value given, right? And 10 mm is the depth that we have given already, and number of cutting passes is 6. So as per that you will feed the data of thread pitch value as 1.25. So number of idle passes we usually given as 2. So that is been maintained. So now the specification detail for thread cutting is also done. So once the machining specification is done, then we will go for tool path. Very first step is always geometry. If you see in the bottom down towards your left corner, you have 3 tabs. One is the geometry, machining, and the tool path. In the geometry, we usually provide the coordinate system, create the line, define the contour, define the part, and define the geometry of the billet. So once that is done, you will click for machining. The other opposite line diagram will come automatically, right? So after that, you will define the tools which are needed as per the tool operation which needs to be done, and you have to select the part also from where to where you need that specific operation. So once everything related to the specifications of machining is done, the very next step is to go for the tool path. So this will simulate the tool related to the operations what we have selected already, and with respect to the dimensions what we have selected already, from where to where we need different kind of operations. So once you are clear with the machining part, you will go and click the tool path. Okay, so once you go and click the tool path, and always remember in turning you will be having only two coordinates, Z and X. So you'll click the tool path. They are showing the beginning dimension of the blank here again. This is done already. Yeah, you will click the tool path over here. So when you click the tool path, it will show you the jaw also. So always before starting, it is better always to save. So we haven't saved until now. You can just type it as program number, whichever. This is our program number 6. So you can save it as program number 6. Okay, so once you click the tool path, you can see that the rough turning tool has come and it is performing the facing operation. So it does rough facing operation and rough turning operation. And then the smooth finishing tool will come and do the smooth facing operation and smooth turning operation, right? So that is the thing what you observe here. So I can zoom out and observe how it is performing. So if you give a overshield value of 1 here, so some amount of material will be retained. So always when you give the value, please see that overshield value will be equal to 0 as shown you earlier while giving the specification details. So now the entire part is removed without any excess part. So now the turning operation has to take place. So now the turning operation will come. It will move in the shape how the part is. Okay, even though you don't have the blank over here, it will move like this until the material is been removed. Okay, so it will still come down. So now the material gets extracted. It will move with the shape of the part how it has to. So again, still it comes down and remove the material for rough turning. So rough turning is done. And now the grooving, the axial, the radial grooving as per the given depth and pec depth. So it will remove the material. And then we have one more radial groove here. So after this, the axial grooving will be done, and then the thread cutting operation. So now, okay, how did it speed it up without? So then you had a twist drill bit which was being used to do the required axial drilling. So after this, the thread cutting tool will come and do the external thread cutting operation. So now it has been completed and you can see all the type of tools which has been used. So we had an rough turning tool to do the facing and the turning operation. Then we used a finishing tool to do the finishing of the turning and the facing operation, right? So then you had we did an contour turning along the part. So this is a symbol because the entire turning was been done. So after that we had an groove cutting, external groove at two different positions. So it shows you the symbol for two external groove. So after that we had an axial drilling operation directly. So it shows the symbol of axial drilling, and then we had an external threading. So we had given from where to where the external threading has to be given, and also the pitch value. Accordingly, the external thread cutting operation will be done. Okay, so this will be the completion of all the operations. So the three tools which is being used is shown over here, and again they are showing some changes if it is needed by mistake. If any mistake is there, so you can delete that particular tool and you can redo it. Okay, so just to show the possibilities if you come across any errors. The same thing has been repeated, so I don't want to. After that, the very first thing is you have to save. Okay, it shows you the cycle time. Okay, so once it is done, I'll pause here. So you can see this icon. If you click, it provides you the cycle time, which is the time required and all details related to the operations. So if you go and click there, you will get that cycle time sheet, right? So it shows you what is the time taken to perform different operations. So you can go and save it within the folder where you have created. So this is one printout which has been needed. Okay, so this is the cycle time sheet. So after that, if you go, it provides the list of tool used. Okay, and then you can provide the specific. So before that, let me show you this icon. Yeah, you can see your G01. If you click on G01, it generates a part program what you were usually writing. Okay, so that also you can click and save it. So this is the NC program which has been generated by the machine. So you can save it within your file with the specific program number what you are using. All these printouts are needed actually for your record as per the new scheme. So the tool list also, it will show which are the tools which are being used. That also if you need, you can take the printout.
Mom, record only diagram or what all, ma'am?
See, in the record you have to write the part sketch. You on the right hand side in the rule sheet you have to just write the key steps what you follow. That was only related to the previous scheme. So now in your 2018 scheme you are supposed to take the printout of the program which will be generated, what I showed
Ma'am,
you before.
Ma'am,
Hello,
our
ours is
17 scheme.
2017 scheme, ma'am.
yours is
2017.
17
yeah
scheme.
2017. I'm sorry, previously it was 2015 scheme what we were following, and in 2017 scheme, right, these printouts are essential and hence all these things are being shown to you.
So, ma'am, what
Okay,
do we
so
write on
print.
the right hand side, ma'am? Like,
Right hand side, in the
yeah, the
left
road.
hand side you will just write the sketch. In the right hand side you will just show the key steps what you have to follow, right?
Like general
Suppose
procedure.
general procedure to create the geometry, for machining the tool path, and finally you will tell that you will generate the program, okay, and other
Yes, ma'am.
details just in a single sheet, that will be fine. Apart from that, few printouts, now what I am showing you, which are generated by the machine, okay, the same thing, printouts are supposed to be added
Okay,
as
Ma'am,
ma'am.
per
those
the.
after after we come to college, no, ma'am.
Yes,
Printouts.
yes, I am not telling you currently, okay, so
Yes, ma'am. Got it.
currently just write the record which is possible from your end, just the sketch on the left hand side, right hand side you will be drawing the procedure, okay.
Okay, ma'am.
So after coming and doing physically in the, I don't know how well like all the programs will be executed and how you will be managing to take the printout. So let us discuss on that, even that discussion is not yet finalized. So based on that you will be taking the printouts. Main thing is you have to come physically to get hands on to use the software, because you have just seen virtually. Looking virtually and operating it individually physically, it has a huge difference. You have to know all the things thorough enough before you go for examination. For that it is very essential for you people, if you come down and practice. Okay, if there is no external examination, then that will work. But when you have external examination, your physical presence is very much needed. So see that you guys will come down and utilize the best efficiently so that you can excel well. Okay,
Yes, ma'am.
thank you. So this is, so hope to see you people at the earliest. So this is the spindle power graph. So if you click on this, you will get the spindle power graph. So that also need to be saved. If you double click on this, the values of the spindle speed, everything will be displayed. So these things, what is the feed rate, everything. And this is just a line diagram to show how the tool is moving. The dotted line will be just the path in which the tool is moving, and the continuous line shows the operation path, how it is performing. So that is the end. And this is a money maker. This also you have to save, and it shows that if you use this material, how much time you can save, what is the cost you are saving, and hence the name money maker. So it depends mainly on the type of material you are using. For different material, the time required might be different, the cost will be different. So you can optimize the time and the cost by going with most best selected material. So if any industry person, this will be very much helpful. So before they go into the actual production process, they can do trial and error and check the material which will be more feasible enough, which will be not too high with respect to cost, and such that it won't consume more time also. So in that way, this capstone will be helpful. I think this is the end of the program of 6. So I will stop here related to this program. I hope at least the minimum basic concept how to perform has come to your mind. Is it so?
Yes,
Yes
ma'am.
or no? Okay. So now let me, I think the PPT is, I'll just share again. Let me complete at least 2 more. Time is less. I want to see the best utilization of the time. So let me share a problem on CapsMill. The very beginning program, it is not a new program, we have done already. Just the end mill operation. Hope the slide is visible. Yes
Yes,
or
ma'am.
no?
Yes.
Okay. So this is the very first program what we did on CNC milling. If you remember, we took a blank and we assumed that the part which needs to be generated is equidistantly placed 25 mm on all the side, and we wrote the coordinate system. The reference we took as 0, 0, 0, and the coordinate system towards our right was positive x, and upwards was positive y, and the value of z away from the blank was positive, and if you go towards the blank, then it is minus z. So this is the coordinate 0, 0, 0, what we assumed, and then we used to write the coordinate for each and every node, and as per that, we used to select the tool of end mill and do the end milling operation path. So this thing is already been done. And now the reverse process. So first we will create the same part. So this will be a common line diagram. So after this, we have to define this line what we have created. So the contour will be developed. So once the contour is developed, so then you have to define this part. So the color changes from red to pink. First, when you draw the line, it will be white in color. When you define the contour, it changes into red. So then when you define the part, it changes into pink. Okay, so later after that, you will provide the dimension for the blank. So then you will select the tool. Here we you have to do two operations. You cannot directly go for end milling. First, you have to do the facing operation. So we will do the facing operation by using the facing tool, and then you will go for end mill and do the milling operation as per the requirement. So this is the thing what we have to do. So now we have to go on with CapsMill. I hope you guys have taken the snapshot of it, or else when I ask you, people won't answer, and I will need the coordinates. Kindly take the snapshot. Better if you take the snapshot of the main program. All of you, have you taken it? Hello, kindly give me a response.
Yes, ma'am.
Yeah, and the dimensions, the coordinates also, I've written it for you people already in CNC mail. The same coordinates you can refer, but it's always better if you write the coordinates by your own. So now I'm stopping this program and sharing my screen for the software. So if I go for CapsMill, program number 1. See, when I go for program, if once the program number is done, so you can make the recording of it. Apart from that, you can generate the program file, the cycle time file, the list of tools, everything in the form of PDF files. Okay, so it comes automatically for you, no need to think about. Only thing you should not forget to store the data. So here I'll go for video 1. Hope my screen is visible. Is
Yes,
it
ma'am.
visible? Okay, so here don't go and run CapsTurn. You have to go and run CapsMill. So this is the icon. So again, the same thing. It asks how we used to do it in case of CapsTurn. So now it is CapsMill.
Uh, Ma'am, I can see only white screen.
It's not visible. The
No,
CapsMill screen is not visible.
no,
Okay,
ma'am.
you told. Okay, okay. I will just again. Now,
No, ma'am, it's still white for me.
okay. Let me reshare it. Is the window visible now? Hello?
Ma'am, I can still see only white screen, ma'am.
See, in my thing, it is showing as shared. Just ask anyone else. Others?
No, ma'am, only white page.
How
No, ma'am,
come
we
it's
can see the white thing.
how can that be? Let me. I'll just open first the video itself and let me share. Is it visible now?
Yes, ma'am.
Okay, thank you. So now you have to click on CapsMill. So kindly click on CapsMill, not on CapsTurn. Double click it. So the window opens. So it asks you to create a new part. So you will get the same type of blank as how you used to get the seat setup for CapsTurn. So here also the units will be in mm, not in inches, and select the material steel for free cutting. So the workpiece material will be the same, and then the table setup, if it is required in different directions, that could be done. So no need for your syllabus, the setup of the table and all. So that is the initial thing, and the other tools are same as you had in case of turning. So line drawing line. Okay, so you have the zooming part, fit screen, and extra part is you can identify or create the whole symmetric in the given blank, either in circular pattern or in the line pattern also. So that I'll come to know. So before doing always, it's better if you save, right? So even saving option has been shown to you. So we save this as .cpm. Any file name with .cpm needs to be done. So now program number 1 has been saved. Okay, so this is the saving icon. So it shows you the coordinates, X and Y axis. X, Y and Z also will come into picture in case of CapsMill, not only Z and X. Right, so you can draw like perpendicular point with respect to some perpendicular plane, all those things. And the arc, you have start and center point, and circle also you can draw with different specifications to draw a rectangle, a polygon, yeah, whatsoever. And now the difference is the points on a circle. Suppose you need to do the drilling operation in a given blank in a circular path. So if you give the diameter of the hole, right, so it will allocate the cursor with plus point at different locations where you want to drill the hole. It is not necessary that you have to go and select the coordinate for each and every hole. It is much more easier. You can specify what is the diameter, right? And within that given diameter circumference of the circle, what is the number of holes you need mainly. So if you give that, you can see the blank with the holes. You will not see the holes directly. You will get a cursor like plus point. So wherein you can use the drilling operation later as per the requirements. First you will locate the center, then you will drill, and you can use a counter boring to extend the hole as per the requirement. Okay, so it will be much more easier if you go with this kind of patterns. Right, so in that way, if you provide a dimension for the diameter and specify the number of holes you need and what is the angle for the first hole also you can define. So now you can see the plus points wherein you can result create the formation of holes. And similarly, if you need a hole across a same line, so then you can define what is the length over which how many holes you need. What is the pitch between the holes also could be given as per the given question. So then you can see the number of plus points here. So that will locate to the number of holes you want to do it along a same common line. And also you can create points on line equally placed and unequally placed also. So this is again to define the contour, and if you need to erase something you can use this. If you need to break a line, if you want to extend, chamfering part, copying, mirroring, all those options you have even in case of CapsMill. Trimming option, chamfering, all those things, mirroring, copying, all the options. Okay, so this is about making you aware about the tools. And again, we have geometry to create the line, diagram, and then machining and the tool path as we had in case of our CapsTurn. So after this, we can start off with the program. So when we want to start off with the program, I have shared you the screen before of the PPT, wherein it was just an end milling operation. So we won't be directly starting with the end mill. You have to do the facing operation. That is a regular thing what we have to do for each and every milling operation. When you have n number of operations to be done, we usually skip the first one, telling that the very first step is facing and then the other operation will be done. But since this is a very first program related to the end mill, we are just showing the facing operation also. So then we will go up with the end milling. So as per that, now we have to give the coordinates. So the first coordinate given is x25, y35. Go back to your diagram, the sketch what I showed you before. Please have a look. I have given the program. So you have a part which has to be created. So that is kept within the blank, and in every side the part is away 25 mm. Right. So with respect to that, I have shown you the reference plane which is considered to be as x, y, z 0, 0, 0. So in that aspect, the first coordinate system what we are supposed to start up is also being shared, so which is x25 and y35. So in that aspect, the first coordinate system will be x25 and y35. Okay, they are not starting from x25 y35, they are starting from x25 y55. From any point you can start, it depends upon your convenience. First is x25. Just delayed much, it has to be shown quickly. X25 and y35. Okay, they have started from there. So the next coordinate is x25 and y55. Please refer the diagram which has been shown to you. So next point is x25 and y55. Right, so you can zoom, then you can identify the line properly. So after that, again you have a linear interpolation only. The third coordinate, if you remember, please see the diagram. Can anyone tell me what is the third coordinate? It is x35 and y.
65.
Yeah, it is x35 and y65. So let them write the coordinate. So next is x35 and y65. After that, you have 10 mm which is moving above. So it will become x35 and y75. After that, you have a circular interpolation, right? It is moving in anti-clockwise direction. So for that, you have to give the start point and the end point, and then you have to give the radius, right? So arc from the start point and end point. So it will show you like this. So once it is showing you like this, you have given the coordinates. The start point will be x35 and y75. The end point will be x45 and y85, but it is not the required arc what we need. Here it is showing that to be specific, you have to give the radius more than 7.07. And in the question, it is given as radius has to be 10. So you specify here the value of radius to be 10. So then you get the required arc. So after this, you will get the value of the arc here as shown. So after this, again, we have one more circular interpolation. It has to come like this. For that, the start point here will be x45 and y85. The end point for the arc will be x55 and y95. So kindly provide the coordinates accordingly. It has to, yeah, now it has been given. Okay, so after that, okay, the end point is given, and then later the radius value also to be given. So it will ask you the radius value you have to give it as 10. So now you got both the arcs which has been created. So then you have a linear interpolation again, go for multiple lines, provide the coordinate system. So it is x55, y95. So you will get the line command here again. From there, now you start. So the next point will be x85 and y95. So kindly type it. You have to refer the diagram and keep the coordinates ready. So you got. From this again, we have a circular interpolation. Right? So for that again, you go for arc from start point and end point. So the start point will be x85 and y95, and end point will be x95 and y85. So then it will show you some odd arc. So then you have to figure out the value of 10 as radius. So then you will get the required arc. So now let me see the coordinates. So it has drawn a linear interpolation. So it is erased. Go for arc. Provide the start point here, 85 and 95. X will be 85 and y will be 95. Then provide the end point. End point will be, see the coordinates in the diagram. It will be x95 and y85. Okay, so you will get this. So after that, you have to draw a linear interpolation line. So the coordinate here will be x95 and y85. Then you will write the coordinate to here as x95 and y35. So it will come here. So then again you have a circular interpolation. For that you have to give the starting point of the curve. So it will be x95 and y35. So then it will come down. The end point here will be x85 and y25. So after that, provide a radius of 10. Go for arc, specify the start point x95 and y35. They took the end point first, x85 and y25, then the start point. So it is showing, if you go a little bit back, provide both the coordinates 85 and 25. First they are taking this, and then it is x95 and y35. Then it asks you the radius. It is looking like a odd curve. So that looks always until and unless you give the actual radius. So here again it shows you have to give more than 7.07. In the question it is shown that R to be 10. So kindly give it as 10. So then you
Oh,
will get the required arc. Yes.
ma'am, what if we give starting point as x95 and y35?
See, sometimes it takes x95 and y35, then we go to x85. Here, what's happening is x95 is more and you're going down, right? With a lesser coordinate. In that case, it won't take sometimes. So, always we go from lesser number to the higher number. Previously, we didn't had that problem because we used to go from x45 to x55, right? So it was an higher up value. So now we are going from higher value to down value. In that case it won't take sometimes, and hence it was taken from x85 to x95. Okay.
Yes, ma'am.
Yeah. So from here again now we have to draw a straight line. So here the coordinate will be x85 and y25. Then again write the other coordinate system here. The last one, what is the coordinate here? X25 and y. Okay, now we need an arc. So now it has been taken from here to here because this is still a lower value. So this is at least in the upper end. So it has taken from x25 to down here, and again you will give the radius of 10. So now we have got the required line diagram. We can't say this as a contour, so it is just a line diagram what we have done. So after that you have to define the contour and then define the part, then draw an blank or the billet and do the facing operation. So now we have to go for draw and select the part. This is too much delayed in the recording. Okay, so define contour, you can go here and select. So it selects one line. So you go for auto contour. So when you click one line, it will select all together. So once you save the contour, the color gets changed from white to red. So after that, you can go and define the part. Draw and define. Yeah, this is done. Then you go for here, no need of part, only the contour, and go directly for the blank. So blank you have to define based on the given dimensions. Okay, so what is the question being given? So there is no specific billet. I think I haven't taken the billet size from the manual. So as per the billet size given, so it will be like X 120 and Y 120. So accordingly, you're taking the dimensions X 120, Y 120. Don't take the value of X, which is a minimum value, in a negative. So let it be always 0. Don't take it in negative value, the reference values of X, Y, and Z, right? And later the Z coordinate. So it will provide you the depth. So always give a depth of around 30 or 40 mm. Suppose the depth of the blank is specified in the question, kindly take down the depth or the value of Z as given in the question. So now you have defined the contour for the blank as well as the part which has to be end milled. So now after this, if you zoom, you will get a clear picture of it, right? So everything is done. So if you go here, if you want to delete, even that could be deleted. So I don't know, they have just shown you how to delete the blank, and again the blank has been created back here. So if any wrong in creating, so it is just to show if what happens if you take like minus X and minus Y. Okay, so here you can see the notice, the difference from the reference plane. So it is X0, Y0, Z0. So if you take minus 10, so then it will be below the reference. So then all the coordinates here gets changed as per the drawing what we have drawn. So it's better to create with respect to the reference point 000. And hence now they are again drawing the blank with the minimum value of x0, y0, and this blank size remains the same, so that you will get the blank with reference to our reference 0, 0, and 0. So that was a difference what I hope you have understood. So after this, we are supposed to do the facing operation, face mill and end mill. For that we have to go for machining, click machining, and you will select. So this is the facing operation. So click on that. So this facing operation tool will come. Keep it on mm. Let the unit of the tool will be mm. We need to do the face mill. So kindly select the face mill. Okay, you don't want an face mill at inclined degree. We need a regular face mill, right? So you will select a regular face mill here. So it asks you what is the diameter which has been needed. So you can select the diameter of the face mill. Yeah, so we are selecting a tool of face mill with a diameter of 63 mm. If you go with 100 mm, it will be huge. So we go with 63 mm. Okay, so we have selected. So it asks us to select the contour from where to where you want to do the face mill. So kindly select the contour. So if you click for the contour, it asks you the work surface. So from where to where you need this face milling operation, right? So you can provide the coordinate or the exact value of amount of material which has to be removed. So we usually slightly remove either 5 mm or 10 mm. That again mainly depends upon what is the blank thickness we have given. If it is 40, you can go with 10. If you have given only 20 or 25, so then it is not suggestible to go for an facing operation for minus 10. Then it should be like minus 2 or minus 5. So depending upon the thickness of the blank, you can select the thickness for the face milling operation, so that this 10 mm will be removed by the facing operation. So that value you have to give, and always you observe. So when you give a tool for facing, it can move in this way, what I've explained in CNC mill already, or else it can move in a contour. So circle inside like this, inside squares, or it can move in zigzag path also. So which is needed, so that you can select. So after all those, right, to exit you have to give like what is the value you need. So if you give like 5, it moves the tool above by an distance of 5 mm. So depth of cut, what is needed, you can give as 5, and then you just click on add, so it gets added up. So this is done. I don't know why it has been shown. So now one tool has been selected for the facing. So then you have to select one more for end mill, because we need to create that part what we have done, right? So this part has to be performed by milling operation. So we selected one more tool for end mill. So it is of diameter 5 mm. So now again you have to, okay, they are showing an end mill tool of lower diameter now. Previously they have taken 10 mm, so now they are showing it for 5 mm. So it also depends upon if you want to change the number of teeth either to 4 or to 5, that you can vary. Usually it is better to go with the regular data, so that will be good enough. If you click hand on tool left, it will rotate from left to right or from right to left. So that will be taken care. So then you have to select which is the path in which the end milling has to be done. So it has to mill the entire contour. So you will say yes, you have defined the contour already. So this entire contour has to be milled out, and as you will say it as S. Okay. So now this part, will the whole contour. So here the circle part has come because we had an circular interpolation here. So for that you need to specify some details. So if you can zoom out, you can observe. So for that you have to provide like which is the type of milling you need across the side. Is it this is all very much essential when you have not a circular path across some. It is like a rectangular or a square path where it specifies all these details. When you have a circular interpolation, they haven't changed anything. It is the same, like the depth of removal is -10, the material width, then what is nothing, wait, they have directly, there was no major change, only thing it was showing the red in color. Actually I thought the allowance to be given for the circular interpolation will be different, but no more changes were done, only thing those two red circles were visible. So that is been removed, and that is the end of machining, and they have directly come for the tool path. Since here it is only specific for rectangular or square, because at the end you had a circular interpolation, I guess that symbol of circle was being visible and nothing much more, because no more changes were being specified over here. And now it has come for the tool path. So this is the blank, and since first we have defined the facing operation, so facing operation will be done in this way for a depth of 10 mm. It is -10 means you are removing the material of for 10 mm. So this is a face tool of diameter 63 mm, and as it is a huge tool what you seem to be. So now facing operation is done. So after facing operation is done, then the end milling has to be performed. So now this is a end mill tool which has come and it is performing the milling operation as per the coordinate what we have defined and the line we had drawn, and we have defined the contour and we selected the end mill and we showed that the entire contour has to be milled out, and as the entire contour is been milled as per the required depth of cut. So this will end up with the end milling operation. And it will move until the required depth of the material is been removed. If it is 10 mm, it will remove with 2 rounds of 5 mm in depth at in a single stretch. Okay, so it again depends upon what is the retract amount you are giving. So based on that, you will be having n number of turns until the required depth of the material is removed by the help of pocketing. It was for 40 mm, I guess, the depth which was given in the question. So in that case, this is the operation which is performed. So then you can save the program number. I think I jumped. So after that, the tool moves away from the blank. And then you can go and click here and get the cycle time sheet. So this is a cycle time sheet which explains you the time duration taken, which is the tool which was selected to do the face milling operation and the end mill operation, which was the cutting speed, what was the spindle speed, what was the amount of material removed feet per rate, okay, per minute, and per revolution also you'll get the data and all the things. You can save it. So the cycle time you are saving it. And then if you click on G01, it is a program which has been generated by the machine. You can save this also to your folder. Save it properly under which program. Suppose you are doing program number 1. Please save all the files associated with 1 so that you can identify which is the program you are doing it. And then if you click on this, it will provide the tool list, which are the tools we have used. Even that could be saved. And then if you click on this one, it provides you the spindle power graph. And if you double click on the graph, it provides you the feed rate, the depth of cut, all those aspects. Even that could be saved. And then for the line diagram, if you come, it will show you the entire construction, how the tool has moved, what all operations are being performed. And here you can trace out the movement of the tool. So here you can identify the movement of the tool for face milling in this way. Okay. So this is just to simulate the trace of the tool. So it shows how the tool has moved, right, to do the facing operation. So this is the face mill of diameter 63 mm. So this yellow color traced out the path, how it has moved to remove and depth of 5 mm. I think we have given 10 mm. So 10 mm of the material is removed in the facing. So then we had an end mill, so which has moved to perform the required end milling operation for a depth of, it depends upon the question in which the depth has been given. So first is a face turning. So 10 mm has been removed, and then we have the end mill, so which has moved still more in depth down. So this is the different view through which the movement of the tool could be traced out. And this is the end milling. How it is moving could be identified until it gets the required pocketing. So this is about the first program, and it has traveled with different rounds until it gets achieved with every depth. If it is of around 5 mm, 5, 10, 15, 20, I think it is a 20 mm pocketing what it has been done by using end mill tool. So basically the line diagram helps you to explain how the tool has been revolved, traced out for each and every operations. So this was about the program number 1 in CapsMill. Hope the things were at least clear enough related to the CapsMill problem. Hello.
Yes, ma'am.
Okay, I will do one more program and I will end up by 4, so that I think 2 more could be done on either Saturday, yeah, Sunday, as per your convenience in the afternoon session. I won't disturb you in the morning. You just have your Sunday and Saturday freely. At any evening after 3 2 o'clock, we can just plan and complete. It's a matter of 1 year, 1.5 hours is more than sufficient to complete 2 more programs. So let me share one more. I'll close this. I'm going for program number 5. Okay, before this, I need to show you program number 5, right? Just a second. Where is the PPT? Hope the screen is visible.
Yes, ma'am.
Okay. So this is the next program. Okay, so here you can see that we have n number of holes which has to be drilled out. So while explaining the problem, I told that here we'll be mainly focusing on drilling the holes. Or else if you consider this entire thing as a given part, then you have to draw one more line that will be the blank, so that the part what we have to be created will be equidistance of 25 mm from each and every distance. But we are not taking in that way. Here in the question it is clearly told you need to create the drilled you need to make the drilled hole for a depth of 40 only. So no face mill is being asked. So now this will be itself our blank with the reference of 000, and these are the holes which has to be drilled out. So the dimensions are given already. As per that, I had explained you the coordinate system also for each and every position. So you have no need of defining the blank and providing the coordinates for all the four corners, as this itself is our blank. Only thing, you need to locate the coordinates for each and every holes. So this we have done already in the previous classes during CNC mill. So now I hope, I request everyone to take the snapshot of the program what we are dealing, so that it will be helpful for you for understanding the coordinates. Everyone kindly take the snapshot of program number 5. Hope you people have taken the snapshot of it.
Yes, ma'am.
Okay, so I will just stop sharing this and share the video. So now I will play the video and then share the screen. Is the screen visible to you all?
Yes, ma'am.
Okay, so this is the program number 5. So as you open, it asks you to either open an existing part what you have developed already, or to create a new part. So we go for creating a new part. So again, you have to go and select the material what we need. So it is steel free. What we select, we will select steel, which is ease for cutting operation. So kindly select steel free cutting, and then you save it immediately, which is the name you want. So it is like CapsMill program number 5, right? And I have explained you, if you want to draw points on a circle in equidistance, if you just provide the diameter and number of holes and the inclination, you can get in this way. So now also we need similarly the holes which has to be drilled out in the given blank, but not in a circular pattern, in a rectangular way, right? So you can go for points which is equally distance placed in a parallelogram also. Okay, so if you specify here what is the number of holes you need and what is the length, for that you have to you have to see with the sketch what I shared you before. So in our question we have an blank of 120 by 120. In that, if you want to provide the number of holes across the length, if you see the sketch, you can see we have 4 type of holes with one distance in, like at a stretch of 80 we have the holes located. Apart from that, we have smaller holes which are located equidistance in between 60 So accordingly, you have to now provide the dimensions to it. Okay, so here, so the number of holes across the line is assigned to be 2, and length is considered here as 50 and included angle is exactly 90. So you can see that 4 major holes are now visible. It is very near to each other. So if you just zoom in or zoom out, you will get to know the actual thing. If you provide a coordinate, it will be exactly at x25 and y25, depending upon the coordinates. So to define the coordinates, you have to go and check with the dimensions. So in the coordinates, if you go for the first hole, it is x25 and y25. So you have to give the coordinate to locate exactly where you want the holes to be drilled out. And hence see x25 and y25 you have to give for the first hole so that it fixes where exactly you need. But it is not visible, so you will zoom in so that it will be clearly visible now. So as per that, you have now 4 locations in which the holes has to be drilled out, right? So one thing is part done. After that, you need to define the blank. So to define the blank, you have to see what is the given question. So in the question, the blank size is given to be as 120 by 120 and the depth is of 50 mm. But here in the question, it has been taken as 100 by 100. In the program, what we have, the blank size is 120 by 120, but here to show they have taken 100 and 100. It's okay. The same thing you can change it to 120 and 120 as per the program. So this is just to make you understand. So now when you have created a blank of 100 by 100 mm, then you can see the blank and the positions in which the holes has to be drilled out. So the coordinate of the holes are proper as per the requirement. If you set the coordinate for the first one as x25 and y25, the remaining holes will be placed accordingly. The second hole will be x25 and y105. The third hole will be x105 and y105, and the fourth hole will be x105 and y25 as per the coordinates we had given in CNC mill. Similarly, it will be located. Only thing, it will make our work easy. You can locate all the 4 holes together automatically by just providing the spacing between the holes and providing the coordinate only for the first hole. So that will help you to fit the holes where you need to drill. Later, the second step is we will define the blank. Once the blank is done, you will just zoom so that it will be clearly visible. So after this, you need some more holes to be done. Okay. So if you see, you can identify 4 more holes to be done. So before that, the center hole is being identified. I don't know why the center hole was needed. The program 5 in our problem had 4 holes here and alternatively 4 holes here, but here it has been considered as 4 holes at 4 corners and 1 at the center point. Okay, you can consider this as only the problem, not a this as a question, not a problem. Anyhow, we will meet in the lab. I will just clarify which with a new program question for this. Okay, so with that aspect, let me move back. So they have identified 1 more hole at the center. So now total we have 5 holes which has been created, which has to be drilled out. For that you need the tools. So first one is the face milling tool. So as we explained in the previous program. So the face milling tool, we usually go with the 63 mm diameter. So now we will select the face milling tool of 63. So in this case it is of 55 what they have selected. I don't know why. Okay, so they have taken 55. Why? Because the blank size now is smaller. In our question, it was like 120 by 120. Here it is taken as 100 by 100. In that case, the diameter of the hole, that face mill, what they have taken 50 will hold good. So they have taken 50 mm. That's fine. So after that, you have to just select from where to where you need to do the facing, from here to here. So you have given the material thickness what you want to remove as 5 mm and return Z. So after that the tool has to move above, so give a positive value of 15, and this tool has to do the rough facing and the smooth facing. So you gave the option for both rough and smooth facing. So you click for both roughing and finishing operation. So then press OK. Click both roughing and finishing. Then you go for cutting method. How you are cutting, whether you want to go in this shape or you want to go in zigzag shape, and which are the number of passes you need to complete that entire removal of the depth, because the facing operation here we are doing to remove 5 mm, right? So how many entries you need, whether you remove one material each in each path, or how it is, and which is the path you want to trace, either it is one way or you need it in a zigzag way. And if you need any inclined version of tracing of the face milling, that also can be assigned. So you will select accordingly which one you need, and also provide the depth of cut and cutting speed. For smooth finish how much you have to give, and for rough finish how much you have to give, and just add. So when you add, it shows the symbol like this. It is nothing but it will be performing the facing operation as per in this way, zigzag way. Okay, so this is a symbol which usually comes in. What you have to understand, be quick, just a second. So after this, the facing operation has been done, then we need to do the drilling of the holes, right? To drill holes you have to select the tool. Okay, so once it is done, so this is a face milling only, I just reversed it back. So after this we will go for drilling. So this is the thing, center drilling. First you have to do the center drilling. We have three versions here. First you have to locate the center for doing the drilling. So first you go with the first one, your symbol, which is the center drill. So here select which type of center drill you want. So this is a central drill, right? Of what is the diameter you need? Of 4 mm is the tip diameter, and others let it be the same. Don't make any changes. Press OK. So you have to select which are the centers through which you want to make the drill. So it will select all the 5 points. So then you save. Okay. So then you can also provide the depth through which you want to do the hole, central hole. So it is of -5. And tool tip depth is given as 2 mm. Then to return, you will move the tool above the blank for 15 mm. So for Z value, you have given as 5. So now this is done. So after that you go for next. You want to do the drilling. First you located the center, then you want to do the drilling. So you have to select a new tool for the drill. Select the unit as mm, then go for drill. Select twist drill. In that you select the diameter which has been needed. So kindly check which are the ranges of diameter which is needed. So here 9.80 has been taken. So select all the points where the drilling has to be done. So you'll click, the color gets changed. Okay, then you provide the work surface depth, how much you need. Again -5 mm. and hole depth what you want to do. So you have to provide the depth of the hole you want to get. So kindly check the problem. It is of 40 mm exactly. Here you are giving the hole depth as 30. First we located the center for 5 mm. Then you are drilling it for a hole depth of 30. So total 35. Then you will use counter boring for finishing with 5 mm more. So total you will be having for 40 mm. So as per that you have to check the values and give it accordingly. So return value for tool will be 15 mm. So that is done. So then you have to use the last tool, the reaming tool. Select all the tools and press OK. And now again provide 5 mm, the last finishing one. The hole depth you will be reaching of 40 mm finally. Okay. So the return value for Z will be 15 or 20 you can give. So that shows that you have defined the tool for face milling, and then you will locate the center, and then you will drill the hole and finally do the reaming. So total we have 4 tools what you have defined and done with the specifications. So once the machining location has been done, then we go for the tool path. So before that, select the machine as Fanuc. So then go for the tool path. It shows you the blank. Then go for simulate. So first it does the facing operation. So it removes a material of 5 mm. So facing has been done. So after this, the holes will be located by center drill. So it locates the holes at the center and other locations where the drilling has to be done. So all the 5 locations are located, and then you will use the twist drill and perform the hole which will be drilled for a depth of 30 mm. So the drilling has been done over here now. Then you use a reaming tool for deep drilling. Okay, so you will get an 40 mm hole which has been drilled out now. Normal twist drill will not help you to go for deep drilling. So if you want to go for deep drilling, then you have to go for reaming tool. So in that you will get the required depth of the hole which needs to be drilled out. So this is how you perform the operation for drilling apart from end milling and facing. And the importance of reaming tool has been studied here. So if you go for line diagram, it shows you the path how the tool moves for the facing operation. And remove the material of 5 mm. So until it is removed, it will trace out the path. On the path what you have selected. So once the 5 or 10 mm has been removed, so then the tool goes to the home position, the tool will be changed and you will use the center drill to locate the holes. So then the center drill will come and it will locate the holes and remove the material for 5 mm in all the locations what we have identified, point holes. So then again this tool will go and the twist drill will be used and it will do the drilling for a depth of 30 mm. So after that you use a reaming tool which helps for an huge removal of the material for an higher depth drilled hole. So for 40 mm exactly, now you have the drilling done at all the 4 locations, sorry, all the 5 locations. So this is almost done. So with respect to different views, you can change and see the location of the tool, how it has been traversed. The same thing you can see in different locations. I'm just forwarding it, the same process in different direction it's been shown. So now we need to generate the datas which are being performed. So if you click on the symbol, you will get the first time cycle data. So this is shown again, a repetition. I'll just forward it. Okay, the cycle time, what we get will be saved. This is the cycle time data, what we get, you will save it. Save it. The program generation, if you click on G01, the program will be generated, and this is for cycle timesheet. So save this as per your name, what you want to give for different programs under your folder. Then you can generate the program, part program. Then generate G01. It gives you the program generated. Okay, so you can see now the program, so that also you will save it to your folder. You can give the same program name for the recording of the part what we have done now. So it will be saved as program number 5. So it is saved, so that it will help you to take the printouts. And then if you go for tool, it will show you the number of tools we used. So this is nothing but the tool list for this particular part generation. So save this also. So then if you go for spindle power, so you'll get spindle power graph, double click on it, you will get the other data as needed. And this is the line diagram again, which has been repeated. So this will end up with the program number 5. So now we have done one program of CapsTurn and 2 programs of CapsMill. So it was the 6th program of CapsTurn and first and 5th program of CapsMill. So now I request you guys to submit this on the Google Classroom as early as possible as per your convenience, so that it helps for me to evaluate. And I have shared some Viva voice questions also. See and try to complete. Don't waste your time and don't keep anything pending, so that even from my end I can evaluate at quicker, and even you can get relieved from the load of submissions related to our sim lab, because you have a other labs also what you have to do it. And my humble request, kindly see that you will submit as per the due dates which are been mentioned.
Ma'am, why you also should we write and submit, ma'am?
Yeah, but if I ask you to sit again for 2 hours, you have time right now, or any Saturday
Not,
Sunday?
we'll write, ma'am, then.
So only I just thought that it is better, so that you, when you find time, you can write and submit me. Okay.
Ma'am, in the record or separately, ma'am? A4 sheet.
Not in the record. You will write in a A4 sheet and then you will submit back in the Google Classroom.
Yes, ma'am, got it.
Okay. So that I will evaluate and I will take that part as your Viva voice, because every program is for 12 marks. And again, 2 marks is for Viva Voice. So now I will consider that part for Viva Voice, what you will submit me separately, and remaining related to your writing part, so that I will evaluate. Okay.
Got it, ma'am.
Yes, then. I hope it is clear for everyone. Any doubts? Okay, then let me take the attendance. Today is 24th. Abdul Khalik Pasha. Abdul is absent.
Ma'am, yes, ma'am, yes, ma'am, yes, ma'am, I'm here, ma'am.
Okay, okay,
Present,
okay.
ma'am.
Where were you sleeping?
No, ma'am, actually, there was some problem with internet, ma'am.
Okay. Akhil KV. Akhil? Akhil is not there. Alok? Alok? Anil Kumar Bastar? Anil? Ankesh Aman? Ankesh is not there. Gautam Krishna?
Yes, ma'am.
Balaji VR?
Yes, ma'am.
Basavraj?
Yes, ma'am.
Beldar Mohammed?
Yes, ma'am.
Chaitanya?
Present, ma'am.
Chandan? Chandan?
Present, ma'am. Present, ma'am.
Chetan Kumar? Chetan? Absent. Dheeraj?
Yes, ma'am.
Okay. Ishant?
Present, ma'am.
Harshit? Harshit is absent. Himanka?
Present, ma'am.
Kanishka? Kanishka? Absent. Kolepara Srinaga? Are you there? Your name is there in the meet. I guess whether.
Yes. Yes, ma'am.
Okay.
I've kept it in the chart.
See, your attendance is very less. I don't know why. What's the reason? Today is your fifth class out of 14. Really tell you, it will be very difficult in the future. You have to get minimum 75%. Kunal Raj Kiran. Kunal is absent. Danush. Danush is absent. Mohammad Ayan. Mohammad Ayan absent. Mohammad Junaid and Sri Prasad. Okay, so please see that you guys will complete and submit me at the earliest. Okay, and you tell me like whether we take the remaining part on either Saturday or Sunday afternoon.
Ma'am, everyone left. Ma'am will decide and let you know, ma'am.
Yeah, Ishant, you just speak with your friends.
Yes,
Take
ma'am.
your time, no problem. At least by tomorrow evening, also, if you let me know, na, so that is more than enough.
Yes, ma'am.
Either on Saturday afternoon or on Sunday afternoon.
Ma'am, Saturday as in after short break, is it possible?
Yes, ma'am.
After
After
short,
10:30.
after 10:30, what I have on Saturday, I have your class only on tribology. I think it is second hour.
Yes,
After
ma'am.
10:30, no problem. For me, no problem.
Okay, ma'am. Ma'am, and then we'll like I'll tell others and then let you know.
Sure, sure, sure. No problem. So you kindly let me know by tomorrow evening also, more than enough.
Yes, ma'am.
Okay, so my intention is just to cover so that when you come from 28th, so you can have the practice so that within 2 days doing all taking printout is really an hectic thing. At least if the teaching part is completed, you will be having some time so that you can practice on. Okay.
Yes, ma'am.
Yes, then. Take care. Have a good day.
Thank you, ma'am.
Okay. Yeah. Bye bye.
Thank you, ma'am.
Thank you. Bye bye.